Okay, so I'll do the introduction. My name is Julian Garcia. I'm based at the Department of Data Science and AI at Monash University, and I've had the privilege to work with Francisco, the speaker, for the last year or so. Francisco is part of a collaboration that also involves Marcus Wagner, who's based at Monash, and John Cook, who's based at the Melbourne Centre for Behaviour Change at the University of Melbourne. This collaboration started back when John was at Monash in late 2022. And we have been working on topics at the intersection of psychology, human behavior, and information technology, particularly around the topic of misinformation. Francisco Zanartu is the speaker, and he's working as a research assistant at Monash University. He has a master's degree in data science from the University of Adelaide, previously studied a Bachelor of Commerce back in Chile, where he's originally from. Francisco will be talking about enhancing large language models with psychologically informed machine learning. And this is basically about misinformation about climate change. So I'd like to also mention that as part of this collaboration, we're always looking for other collaborators, and particularly Francisco is also on the job market. So just keep that in mind. Francisco. I think you're muted, Francisco.
I'm muted.
Hi. Sorry.
Okay.
Yeah. All right. Thanks, Julian, for that introduction. And thanks to Optima for organizing these seminars and inviting me to speak about this project I've been working, along with Julian, John Cook, and Marcus Wagner. Today, I'll be discussing combating misinformation, enhancing large language models with psychologically informed machine learning. I have this feeling that we are living in exciting times and how technology is revolutionizing the way we live and interact, especially on social media. But it's also alarming to think about the possibilities that large language models give to spread misinformation. So through this project, we have been exploring ways to give a good use of large language models, or LLMs for short, in efforts to play a part in mitigating the single biggest threat humanity is facing now, which is climate change. I'm quoting this from the United Nations. Climate impacts are already harming health through air pollution, disease, extreme weather events, forced displacement, pressures on mental health, and increased hunger and poor nutrition in places where people cannot grow or find sufficient food. So I'll start indicating why combating misinformation is important. I want to reinforce this idea with what science is telling us about climate change and about why climate change misinformation is a big issue. Climate misinformation hinders climate literacy and policy support for polarization. And even though the high-level consensus among experts about the reality of human-caused climate change, efforts to communicate climate reality face challenges, leading to climate silence. So misinformation is perceived by the public as more novel than factual information and consequently spread faster and farther than through social networks than through news. Once people accept a piece of misinformation, they continue to be influenced by it, even if they remember a retraction. So researchers began to focus on rapid response solutions that can reduce the spread and influence of misinformation, or what Hassan et al. Describe as the holy grail of fact-checking. The holy grail of fact-checking is ideally a completely automatic fact-checking platform that can detect a claim as it appears in real time. And this is really important because the challenge is that the human fact-checkers frequently have difficulty keeping up with the rapid spread of misinformation. Well, now I'm going to discuss how are we tackling this misinformation problem. An optimal debunking strategy combines factual explanations and expose rhetorical technique addressing the dual dimension of misinformation impact. So in this project, our focus is on exposing rhetorical techniques, and we are doing it by leveraging the critical thinking methodology developed by John Cook and his colleagues. In very, very simple terms, the method is the following. One deconstructs a claim into premises and conclusion, and then we check each of the premises if each of these premises contains a fallacy. So, for instance, in this example, the premise 1 commits ad hominem fallacy, accusing science of deceptive or unethical acts, and premise 2 commits misrepresentation, as it assumes science is driven by political agenda. And what are the rhetorical techniques that we are exposing? Well, we're using the Flick taxonomy developed by John. So in this project, we are using a subset of 12 fallacies within this Flick taxonomy, the most relevant ones, and we catalog them into 2 broad groups: fallacies that follow an structured pattern and fallacies that require background knowledge to be identified. So, for example, an hominem fallacy involves attacking a person or a group instead of addressing their arguments, and its structure would be like group A, for instance, has a negative trait, and therefore A is not credible. Whereas slothful inductions refers to ignoring relevant evidence when coming to a conclusion. So it's not only the structure of the argument, we necessarily need background knowledge in order to identify relevant what relevant evidence is being ignored. Well, the fundamental building blocks of these LLMs are the word embeddings, which are these numeric vectors encoding the meaning of words. These vectors are structured in such a way that words closer in the vector space are anticipated to have similar meaning. A really nice illustration of this is this paper from Grant et al. And if you look at this image, you will see that the smaller animals are in one direction opposed to the larger ones. And what does this have to do with our project? Well, the main challenge in classifying fallacies about climate change is that our subject is restricted in this vector space. So it's expected that we could not have enough features or words, if you like, to classify a particular fallacy. And it's also expected to find a great degree of overlap between them, because they tend to be clustered in the space. So in that sense, the CART taxonomy developed by Cohen et al. Helped make sense of this overlapping nature of climate change misinformation. The CART taxonomy classified contrarian claims about climate change into 5 broad categories and their subcategories. So the 5 level 1 claims are: global warming is not happening, human greenhouse gases are not causing global warming, climate impact are not bad, climate solutions won't work, and climate movement or science is unreliable. So with that in mind, we build our dataset using a techno-cognitive approach. This techno-cognitive approach is the synthesis of past psychological, critical thinking, and computer science research in order to develop an holistic, interdisciplinary solution to misinformation. On one side, we use the critical thinking methodology in order to label the most important fallacies on each claim. And then, because we use different sources to build our dataset, we employ computer science technique to further enhance the quality of our data. For example, we remove exact matching claims. We use embeddings to calculate similarity and keep the most representative claims. We use distances to ensure labels were well annotated and to remove outliers. Additionally, we create this heat map that help us explain the overlapping fallacies on each claim category. And we divide our dataset into train, validation, and test. Then we establish some baseline. So first, a 0R classifier, which is a classifier that always selects the most frequent class. In this case, ad hominem with 37 samples. It achieved an accuracy of 0.14. And we were, of course, also interested to know how well these LLMs out there can perform with zero-shot prompts classifying claims. We test Google's PaLM2 and OpenAI's GPT 3.5. We observed that PaLM2 left 28 samples out of our 256 samples from our test sets without assigning a label, and GPT 7 samples. That is, answers to the prompt such as this text does not contain any logical fallacy or none of the above or things like that. Both models, most frequent prediction was false equivalence and cherry picking. Then we evaluate 8 transformer models from the Hugging Face library from maximum 30 epochs using validations set for early stopping and the cross entropy loss function. So we conduct an iterative analysis where we explore first the learning rates, then we change the cross entropy loss function for a focal loss to focus on the most hard to classify samples. Then we add the weight decay, and then we also explore low rank adapters or LoRa. And the overall best model was the Berta with an F1 score of 0.73, which is significantly higher than our baselines. So if we look at the results in more detail, the greater F1 scores was observed for fake experts, anecdote, conspiracy theory, and ad hominem. In contrast, false equivalence and slothful induction exhibit the lowest F1 scores. And we can think that false equivalence could likely be, the results of false equivalence could likely be explained by the relative lack of training samples, was one of the most underrepresented labels. However, slothful induction exhibit a more even distribution across all the topics on the GARD taxonomy, and therefore more prone to confusion and overlapping with the other labels. So, well, we have made some efforts to make our model available on Hugging Face. You can find it on this link and Zanartu/Flick. We add the fallacies definition here. And please feel free to try out this app and play with different claims if you are interested. we also include some examples from our dataset. Additionally, we are developing an automated model that combines work from Rojas et al., or classifier and generative models to identify, classify, and debunk claims. So for instance, in this example, this application is calling a binary classifier developed by Rojas to detect whether a claim contains a fallacy. If there is a fallacy detected, the app then calls OR classifier to assess which fallacy is contained in the text. And finally, it calls a generative model, in this case, Google's PaLM2, and produce a response as recommended by the debunking handbook by Stefan Lewandowski and John Cook. And finally, we are currently exploring two avenues for future work. So on one side, we want to continue developing our application towards a React-style agent. This is an agent that autonomously decides how to address misinformation. This could involve, for example, deconstructing the argument, using our classifier to identify fallacies, or, for example, adding context from internet sources. On the other side, also inspired by this paper, learning from mistakes, this is likely to be a more extended work. We plan to teach a language model or techno-cognitive approach, so aiming to create an accurate agent for debunking misinformation and hopefully bringing us one step closer to achieving the holy grail of fact-checking. And that being said, this is the end of my presentation. Thanks for listening.